Hello, my name is Peter Raymer, and today we're going to talk about multi-threading in D365. We've talked in the past about sysoperation framework batch jobs as well as run-based batch jobs. Those are jobs for allowing the system to run tasks, processor-intensive tasks in the background instead of having you as the user wait for it. And those are great most of the time. Those are plenty sufficient, and you can make those run really quickly. But then there's a few different scenarios where you may have a lot of records or a lot of processor intensive work that needs to be done, and you really need multi-threading. You need to be able to take advantage of multiple threads within the processors to process these jobs at the same time. So that's what we're going to talk about today. So a quick few example use cases is maybe you have a whole bunch of sales orders coming in from a website or some external platform that's using OData or the data entities to insert records into a staging table. Now you need to turn that sales order information into sales orders in D365. Or maybe there's just some other records that you have a whole lot of that you need to process. I know picking workbench is a very intensive process as well. So let's look at how we do multi-threading in Microsoft Dynamics 365 for finance and operations. Before I get started, I want to kind of give you a couple references that I was able to learn a lot from and then kind of make some improvements from. So first of all, there's this article that's been around since 2012 on batch parallelism in AX Part 1. You can see there's Part 1, Part 2, and Part 3. They go through some different types of doing multi-threading that we'll briefly review as well. So we've got batch bundling, individual task modeling, and top picking. But this was really written for AX 2009 and 2012. And then thankfully Val updated this for sysoperation framework in 2018. Well, I'd like to make a few more improvements as well as record a video that hopefully people will find helpful explaining these different multi-threading tasks as well as walk you through how to write that code. So let's get started. So there are a few different ways you can do multi-threading, which really comes down to you've got what we're going to call a work item, which is a standalone task that you need completed that can be completed independent of the other work items. So in the case of orders coming in from a website or an outside system, this may be a single staging table record or a staging table record and its lines. That can be processed and turned into a sales order independent of everything else. Multi-threading is what's key to it is you need to define what your work item is, what can be done independently. Something that isn't independent is you can think of invoicing a sales order. There's a lot of journals that need to be written to and updated. Those really can't necessarily be done independently, so you wouldn't be able to turn that into multiple threads. Whereas if you've got a single unit, or you can clearly put a box around a task of work and say this can be done independently of all that work, that's what we're going to call a work item. And there's three common approaches. One's called individual task modeling, one's called batch bundling, and top picking. I definitely recommend you read Val's article for some details on it. Basically, he came up with the conclusion that really top picking is usually the most efficient way of doing it. But let's talk through what those are real briefly so you can kind of have an understanding of those. So the first one is individual task modeling. The idea behind this approach is that for each work item, you create another task, as many tasks as you have work items. The problem with that is, let's say you have 1,000 or 100,000 records. You can't really spin off 100,000 tasks. There's just not that many threads to a processor. You really shouldn't go beyond 16 threads running at the same time. Otherwise, you might have performance degradation. So this works really well when you've got maybe a set number of tasks. Maybe you've got an enum with a particular type of record, and you say, okay, for each type, I'm going to put these off to an individual task. The downside is maybe the work involved in each one of these tasks is not even, and then you've got certain tasks and threads finishing early, others still processing for a while, and you're not taking advantage of the full power of all the tasks 100% of the time. So again, there's some great things about this, but it's also maybe not our best choice. Batch bundling is another type of multi-threading. In this case, we basically look at a number of records. We put a bound around a number of records. Maybe we grab 10,000 records and assign it to one task, and then another 10,000, assign it to another task, and another and another. And we can do that by like counting the rec IDs and saying, okay, this task, you're assigned all the records from rec ID 100 to 10,100, and then you're assigned the next 10,000, something like that. Or we could do that with a date range as well. The downside again to this approach is what happens if the time it takes to process those 10,000 records is not the same across different tasks. You can think of a sales order. Maybe a sales order has one sales line, or maybe another sales order has 100 sales lines. If we assign sales orders or a group of sales orders to each one of these tasks, then one of these tasks might finish early, and then they're just going to stop and sit around and wait for the other tasks to complete. They'll grab their next bundle until there's no more to grab, but at that last piece where there's a limited set left, we're not going to use all of the advantage of these tasks. So that's fine, but not necessarily the greatest. Lastly, we have what's called top picking, and this is what I'm going to show you how to do today. Top picking is kind of like batch bundling, but we're basically having a bundle of just one work item. And so essentially what we do is we've got a long list of all our work items, and our tasks are going to pick one off the list of our to-do list. It's going to grab one, work it, and then grab, once it's finished, it grabs the next one that is unclaimed on the work item. So here you can see 1, 2, and 3, and then it would just keep processing. So if certain work items finish quickly, great. One task is going to be able to process more records than the other, but all of the tasks are going to stay busy essentially almost 100% of the time. Once it gets to the very last work items, sure, you may have one task finish and another task still running, but because we're only processing one work item, the assumption is that's going to be the smallest possible amount of time. So let's get into the code, and I can show you how to write that code. Before we do that, I want to give you a quick overhead view of the code we're going to write, because there's just a few different classes we need to write. So initially, we want a sysoperation framework job that we can schedule. This way it can be on a recurrence. That's where this is a little different than Val's example. In Val's example, he's got just a one-time job where he's creating some tasks. Here, we're going to create a sysoperation framework batch job so you can schedule a recurrence and say, okay, run this once a day or once an hour, whatever you need it to do. This job, its only task is to create however many tasks we tell it to. So I've actually had a parameter where you can tell it how many tasks you want it to use. Between 8 and 16 is usually great, but it can be 0, 1, etc., or not 0, but 1 to 16. But this is going to create our tasks. Then each of those tasks are actually going to be their own instance of a different sysoperation framework batch job. And that job is going to process our work item, in this case, an in-processing record. And then we're actually calling, just for the sake of abstraction, we're going to have that batch job call a class that is capable of processing a single record. You could put all this code in the sysoperation framework job, but I find it good practice to move that code out. It helps ensure that all of what you're doing can be done on a single record, and that you're not referencing other records that are in our staging table or anything that would cause this multi-threading not to work. So here we've got our parent sysoperation framework job. We've got another one for each task, and that's really just calling code in a third class that's going to do it. So now that you kind of understand the framework, let's jump into the code. All right, so here's our code, here's our project, and I'm going to walk through our first sysoperation batch job. So here's our contract class, and I'll link to the article that has all this code, so I definitely recommend copying and pasting it from my article and then making an adjustment from here. But essentially we've got a data contract class. If you're unfamiliar with how to write sysoperation framework jobs, I recommend you go read and watch that video first, because this will make more sense. Essentially we have three classes we need. Here's our contract class. Here's the parameter that allows us to tell this job how many threads should you spin off, or how many tasks. We kind of use threads and tasks a little bit interchangeably here. Next, we've got our controller class. This is just our standard class that kind of tells it what to do. It's going to tell us to run the process method on the multi-threading create tasks service class that we'll look at a second. It allows us to specify the caption of our job, and then the rest of this is pretty boilerplate sysoperation framework. Now we get to the service class and this process method. This is where the code kind of gets a little more interesting. Essentially, what we are doing here is we are counting the number of records in our staging table that are in a status of to be processed. So allow me to explain our staging table. I created a very generic staging table. You may have yours that'll look differently, but I've got a field called processing status, and I've got a value just for the fun. You may have a whole bunch of sales order information or other data that you're processing, but it's important that you have some kind of status so we can keep track of which records have been picked up and which ones still need to be picked up. So essentially I'm using this enum, and this enum has a to be processed status. So that's when records come in from the outside system. In processing is once a batch job thread has picked it up, we're actually going to move this status to be in processing to say these are all the ones that the batch jobs are allowed to work on, and I'll explain why that is in a second. And then once it's complete, we mark that record as processed. If there's an error that occurs, we can update the status to error, figure out what the problem is, and reprocess. You could have just these two statuses, to be processed and processed, but having in processing is important, and I'll explain that a little later. So okay, so we've got our batch job. We're going to count how many do we have to be processed, just to make sure we do have some. We don't have to do this, but this is a nice check. Once we make sure that we have more than 0 records to be processed, we're going to mark all of the records in the table that are in a status of to be processed to be in processing. This is essentially telling the system, hey, these are all the records we want all of the tasks to process. And again, I'll explain why that is in just a little bit. Next, we're going to create a batch header. This is what allows us to do the multi-threading. From there, we've got a for loop where we are looping around the number of threads. So here we actually called contract.parm number of threads to get out the number of threads into a local variable. Then we just have a simple for loop that says create a new constructor of this new class, multi-threading get work item controller, and add that controller to the batch header, and do that for the number of tasks we need. So in this case, if we say we need 8 tasks, this is going to loop through 8 times and create 8 separate instances of this controller class. And then finally, we call batch header.save. That's what tells the system, okay, go ahead and start executing all of the tasks that you've added to this header. So that's all this job is going to do. We've got 3 classes, but the service is just in charge of creating a instance of another sysoperation framework batch job for every thread we have. So this job's actually going to run really fast because all it has to do is create the threads, and then it's done. It's these threads that are actually going to do all the work and take a little longer. So next, let's look at our next sysoperation framework batch job. I'll go to the controller class first. This controller class is, again, pretty boilerplate. We're going to say run the process method on the service class. We're going to give it a default caption of get work item. And then all of this is very, copy and paste as well. So let's get to the service class where the real interesting pieces happen. All right, so this is our process method. Essentially, what we're doing, this is all it is this one method. We're doing a do while on the staging table, and inside the do while, we've got this statement, select pessimistic first only staging table record where the processing status is in processing. So it's basically grabbing one from our list of records to process. Then it's calling this other class. I told you we created a third class just for abstraction. This is just a normal class. We pass in that staging table. This process staging table is going to do whatever it's supposed to do. Create a sales order, process the record, whatever you need it to do, you put in this code. Then once it's done, as long as it's made it this far, it's going to move this status to processed and then update the record. If an error happens, we can either TTS abort this record, or we can set the processing status to error and then update the record for review. Either way. But the concept here is we're just grabbing one record at a time, and we're going to keep doing that as long as this first only statement finds another record. So, okay, that's interesting, but what makes it so that if we've got 8 of these running at the same time, what keeps the system from not processing the exact same staging table record across all those threads? And that this is really the secret, and the secret to multi-threading is this pessimistic lock right here. This pessimistic lock says, okay, lock this staging table from all other processes from using it. And then additionally, the second half of this key is we need this method right here, read past. And so when we pass true into this read pass method on the staging table or on this table buffer, what we're telling it is whenever you run a select statement, skip all of the records that have a pessimistic lock on it. So if there's 7 other threads running at the same time, they've locked the first 7. When I run this first only, it's going to skip all of those, even though they've got a status of in processing. It's going to skip it until it finds one that doesn't have this pessimistic lock on it. And this is the key to making sure that all of the 8 threads are always grabbing the next one on its list. So again, you can kind of remember this here, where each thread is grabbing one and it's skipping past any that are not done. Okay, so that's really the code. I'll show you a bit more on how we test it and make it work. But I want to make one other statement of why are we using this in processing status. And the reason for this is, consider a scenario where maybe you've got 100 records in your staging table. You kick off this job and you've got multiple threads that are chewing through those 100 records. They're grabbing them all. Well, let's say 2 of those 8 threads finish, or maybe let's say half of them. 4 of those threads finish because there are no more staging tables records to process. Well, right after they finish, those threads finish and they stop completely, maybe some new records come into your staging table. Maybe your e-commerce platform or whatever sends more records in the system. Well, your remaining 4 threads are going to see those new records, and they're going to pick them up and keep working on them and work on them. And then maybe a couple more of those threads stop because there's no more, but the last one's not quite done. And now you get some more records in. Now you've only got 1 thread processing all the new records because the existing threads that have already stopped, they're no longer looking for new records because at the time they last checked, there were none, so they stopped looking. And so in the end, you've only got 1 thread or fewer than your 8 threads processing the work that you need. And that's not ideal, and that could go on for a very long time. So instead, we really want this in processing flag to essentially say initially, update all the ones we have to in processing, and then make all of these threads process that chunk of records. If new records come in, that's fine, they'll queue up. All of these threads will finish, and then your recurrence of the main batch job that's creating these threads can run again. Maybe you've got that running every 15 minutes, once an hour, once a day. Once that starts, it's then making sure all of the threads are running and that they're all processing the work that's available. That ensures that you're always making use of all your threads and you're not letting ones kind of go by the wayside. So it's a mixture of this top picking as well as using the frequency of the recurrence of your batch job. That's really the key. And so that's it. I've created a staging table form that just shows all the records. Whoops, not that one. That I've got. I went ahead and I ran this create staging table one-time job just to create some fake data for me. So it's going to create 100 records in to be processed. It's got a value of just a number between 1 and 100, just so I could see what that looks like. We can go back here and restart my thread so you can see here's my 100 records. And then lastly, I wanted to show you what's in my processing staging table class. This is the generic class that you're going to replace with your own code. In my case, all I'm doing is I'm printing out what value I'm processing, and then I'm actually waiting for 5 seconds. So if we do the math, if I'm processing 100 records at 5 seconds each, if this were to run without multi-threading, this would take 500 seconds to run. But if instead we run this with 8 simultaneous parallel threads, then 500 seconds divided by 8 is actually 62.5. So we're expecting this to take, a little over 62 seconds. So let's see if that's the case. So I also created a menu item for my batch job for my first batch job, so I could kick it off. And so let's go and do that. And then one more thing before we do it, there is a server configuration. The server configuration form has this maximum batch job threads, and by default this is set to 8. but you may want to set this anywhere between 8 and 16. If we go to Microsoft's documentation on it, you can see it here. They really recommend that you don't increase this past 16 because you may have performance degradation because of that. So typically you can set this anywhere between 8 and 16, and basically no matter what we put in for our parameter, if we passed in 100, it will only use the number of threads we specify here. So I could come back in here, change this to 16 if I wanted to and save it, but we're only going to use 8. So you can see here there's even a warning that says if you select more than 16 you're going to have problems. So I'll leave it at 16. Then I'm going to go to our menu item that I added here under tutorials, multi-threading, create tasks. That's again our first sysoperation framework. This I can enter in 8 for. It's left 8 from the last time I ran it. I'm going to check this batch processing. I'm just going to run it once, but the power of this is you can set up a recurrence to run this as frequently as you need to. So then I'm going to say OK. It's going to then start my batch job and create my thread. So I'm going to go over to the batch jobs form just to show you kind of what's happening here. And what I can do is I can go to this job ID and pick largest to smallest, so I can see the most recently created one, and I can see, okay, this multi-threading create task already finished. It now is executing this get work item batch job. And if I click on the blue text here, this is where I can see there are actually 8 threads all executing right now. And so I can give them a period of time to maybe finish running, and then we can see how long they took. Remember, if these were running individually, they would take 500 seconds to process all 100 of these records, but if they're running in parallel, they should really only take the 62 seconds. So we'll just give it a second more for this to finish. And then we can validate if that's actually the case. So I'll click this refresh button. I think that'll do it, or I can click maybe the reload button. We'll double check. I think I actually wanted the refresh button, so I'll go back in here. We'll go back. I can actually see this one ended, so that's great. Let's drill in, and sure enough, all of these have ended. And if I make this maybe a little bit wider, we can see the start and end time of each one of these. So if I look at that, it took a minute exactly for this thread to run, this one, this one, this one. They actually all took, or these took a minute, this one took a minute and 5 seconds. Right? So just over the 62.5. So pretty close. It's important that we're seeing these relatively balanced, and you can see how fast these records were processed, and they were essentially processed almost 8 times faster than they would have otherwise. So this is really great. Again, I would say most of the time when you're running these batch jobs, kind of in conclusion, you can use just a single batch job thread, or you can set up a couple different batch jobs with slightly different parameters. That's usually great. You don't usually need to code a top-picking multi-threaded job, but you may have a specific case where you really need the performance, and in that case, this is how you create a batch job that's multi-threaded and runs really, really fast. So hopefully you learned something new today. Thank you so much for watching. I really appreciate you watching. If you liked the video, click the like button. I also invite you to push the subscribe button as well. If there's other topics you would like to see a video on, please post in the comments and I'll see what I can do. I hope you learned something new today. Thank you.